up so that listen to you. All right. So remember that when we're doing this, guys, we are following the directive from CXC based on the topics I give. If we go to it, 6, 7, 8, those are topics we must touch. Because based on what we have done so far for the entire year, well, these will be the topics. Those will be the topics that we know the least about. So let's try and get this one out of the way, at least for this week, and give this information some time to soak, and then we can find past paper questions in between to sort of at least make sure you retain the information. All right. So let me see something here. I think I see one here. All right. Here's another example. I think I like this one. It's on the matter of cracking. CXC is an exam where they're easily inspired by things happening around. Another example here of cracking. All right. Everybody seeing this?
Yes,
They,
sir.
yeah. So look out for questions here. This another example. They use C10H22. The correct name for C10H22 here is we're saying is decane. Prefix DEC stands for 10. You know. In fact, the month of the year, December, even though we say it's the 12th month of the year, that month really came from the first calendar that had 10 months, and December was the 10th month in that calendar. And but they introduced 2 more months. One of them June, July really, which was named after Julius Caesar. So they moved from that calendar to the one we're using with 12 months. And so December really means the 10th month. But anything that starts with DEC, as in the word decimal, decade, as some of you might probably lived a decade already. Some of us probably 2 decades, maybe 3 or 4, and 5 and 6 in my case. So we have decade here, means 10. All right. So we have C10H22, and that's heated to 800 degrees with a catalyst used. If they ask which catalyst they use here, just in case CXC want to pressure on the brain, we can use couple catalysts, Let me just write the name of it. Really, a substance known as pumice, which is a sort of stone that has aluminum in it. We could use aluminum oxide, Al2O3. And we could use our pumice. That's specific name of the catalyst used in the cracking. So if we're doing this lab at school, which unfortunate that we're face to face, and so mess up this lab couldn't be done virtually, but that's what cracking is. As we say, guys, we need definitely need more time with you guys to show you some stuff, all right? Because as we political things here, and CXE will be packaging questions in such a way that they might not be asking you for a lot, but in order for you to understand certain things, you need some more exposure. Like I don't want to show you a video here where this is done in the lab. Very nice lab though. Something I think I haven't. Well, I've tried it once, but not my favorite lab bowl, but a very nice thing to do. But then what they're saying here, the cane is heated at this temperature, which you can't get to 800 degrees in a lab unless you're using a torch. Well, if you're using a blowtorch, when I do those things I used to weld up body shop to weld up cars. That actually gets up to 3,000 degrees. So get up to 3,000 degrees on a torch, but usually we put this thing in the in a test tube when we're cracking it. That's when we're doing it in the lab. So, all right. So let me see. See if I can.
Sir,
Yes, go ahead.
what is the word you have beside it? Al2O3.
It's actually pumice. It's actually pumice. As I said before, it's a type of rock. So this is aluminum oxide. Or we could use pumice. So it's a certain type of rock, really. All right. Yeah, give you more information some other time. But this is just an example really of one type of cracking that they do. They take a C10 and you do this. But you get ethene, and they said the ethene here is used to make plastics for polymers. CXC didn't indicate on those topics that we are going to get a question on polymers. But in case I ask you what is one use or state one use of ethene, and the main use of ethene is to make plastics. Polyethylene is a plastic. All right. And then of course we use it to make the plastic used to make pipes. So although know how the pipe them stay, the plastic pipe them, that's ethene you use as a raw material for that. Propene as well is used for that. So you get ethene, propene plus pentane. So as you can see, this C10H22 breaks up into something, given the formula C5H10. This is used, the pentane is used in petrol. But as you know, based on the name of the gas that you get at the pump station in Jamaica, the name of that gas is actually octane. That's what so what they basically do, they use, I think pentane is used in small amount, but they have a thing where you buy the marks if you want 87 or 90. All right, so Tarashi, you should be familiar with that. Which one of them you use in your car?
90, E1090.
E1090. It's your best. Well, yeah. And this is showing you that 90 means you have 90% octane in there. If you use E10, 10% of it will be alcohol, which is used to cheapen the gas really. So I think they adapt cars to use that. So initially it was a problem though. And then people used to say light and say they don't want to E10, they want the regular gas, but that over time got expensive. So them try and modify the thing. But C octane, C8H18. That's the gas your engine tends to prefer. So that's why you buy it. And again, that's getting very costly nowadays. Right? They're supposed to know so the gas price might go up. So
Sir, I was gas come like no. Best
well,
move
yeah.
with not even one stroke. I don't want to look at sir.
Well, yeah, I know. But you have some small cars that still can carry you for 2 weeks with $2,000-3,000 worth of gas. It's just the type of car you decide to buy. If you're buying a Mark X or or Axie, or some of them cars, they really burn gas because people drive them too hard. Those things. So that causes your car to use up a lot of gas there. Well, all right. So ethene, propene, pentane, and we have these as what you get by cracking decane. Again, decane by itself really can't find a use for it. It is too heavy to use in your car engine, and too light to use for other stuff really. So yeah, we have to crack it. If we somehow get it in the distillation process, we have to crack it. So this is why island job, island gas, there are a lot of jobs there in that area. Though the engineers, the petroleum engineers are some of the highest paid engineers. They really get a lot of money because it's a big business. If you are in the oil industry, you are in charge of overseeing all of these things. You could be a contractor that they say, well, you're gonna are a project manager really, that they will ask to oversee the production of a certain type of raw material, and your job is to ensure that the plant is running in a stable manner. In fact, it's all about data. You have to watch so these boilers that they have here, I'll show you how the plant structure goes stay on a real life point of view here. All right, because this will inspire you to want to make some money in the future. All right, everybody seen this? So this is what an oil plant would look like, a modern one. There you go. So we have it. All right, so this is it. They have different towers, but these towers are different processes going each time. But most of them are connected to computers, so a person have them tablet or even even them phone them can use to monitor what's happening. Remember now the heating of the oil is a constant thing. So it's not like they might get some oil like no, and then they might just heat it that time and then wait on it. No. It's a 24-hour thing. So the constant production. So you set up the plant and you monitor everything. You check. You have digital sensors that check the levels of everything you're trying to make. And that's how you know the place is running efficiently. So you want to know that at the end of the day, a man come in, say want X amount of fuel, want some petrol. When you send this off to the gas station, so then can do the mixture. So when you get the pentane, you when get your octane, you when mix them, and get a blend of gas that can be used in cars. So of course some of this have to go to the car manufacturer as well. So they have to test it to see if it works well with the cars. If it is that they want to come up with a different type of fuel, then that goes to testing and development. So this is big business. If you have if you have an oil plant, this is what the Bush family in America do for a living. George Bush, who was the former president, that's what he did. This type of stuff. So that's why he's so rich. He's wealthy, even wealthier than Obama. Probably even wealthier than Donald Trump too. It's big business. I don't think this there. All right, guys. So that should just expand your mind into what the sources of hydrocarbon could entail. There's just natural gas, the preparation, the processes, them. That's it. As it relates to now to the introduction to organic chemistry now, that is where we specifically speak to alkanes and alkenes. So, and if we scroll through a lot of the past questions, they do ask a few questions about it. All right, so as a matter of fact, all right, so no, they went a bit haywire there, but let's scroll through and see what those organic questions would look like. So seem to be some sort of a lag in this machine here. All right, so they went there to ask about detergent here. All right, here we go. Right here, let's go to this. They have here this different type of organic molecule. If we go here, there you go. So now this should be speaking to you now. All right. So this now, guys, this is more related to that topic here. As a matter of fact, I think I should copy it. Let me see what is on the other page. Yep. This is a big question, guys. All right, I'm going to actually copy this, guys, and then work through this because this is going to the introduction now to the hydrocarbons. So those things that we just spoke about earlier, going deep into this question, into these topics, as deep as we can go. All right, let's drop that there. Everybody seeing this? All right.
Sir, kind of blurry.
Okay. Well, that has to do with your connection, Benito. All right, so but it should be. But seeing this, Tara, Casey, Shantai.
Yes, sir.
Yes, sir.
All right. Still there, Missy?
Yes, sir.
All right, Daniel and Michaela.
Yes, sir.
Okay. Yeah, Britannia, and of course Benito should be there. All right. So now, guys, talk to me about this now. Compound F and G are shown below. These are hydrocarbons. So what can we say about compound F? And what can we say about compound G? Even without looking at the question they're gonna ask you, what do we know about them just by looking at them? What can we say about them?
Sir, we see a double band.
Oh. Now you see a double band. There you see a double band. All right. That double band. Which one has a double band?
One to your right. G. It look like G.
Yeah, let's get deeper into it. All right. So we're going to pick up that double band. All right. And of course, let's highlight that double band. It's right there. So everybody seen that double band?
Yes, sir.
So what does all right? So what do we know about this double band? What is this double band telling us?
It's an alkene, sir.
Okay, Daniel is saying that it's an alkene. We could go ahead with that. So double band. All right, as a matter of fact, we need to be specific about the double band because I don't want people seeing a double band with carbon and oxygen and calling it a double band. It's a carbon to carbon double band. Let's be clear with that information. It's a carbon to carbon double band. So we have to be specific with naming that double band. Yeah. So it's a carbon to carbon double band. So carbon to carbon double band, that is an alkene. All right, everybody see that? I would remember this, because I don't like the silent treatment that you guys giving me. It is showing me that it is showing me fear and lack of knowledge and all that sort of negative thing. Right. But regardless, I have to motivate myself to continue because you guys need to learn this thing. So anyway, this double band means that it's an alkene. All right. And they did say introduction. So Right, so they did say introduction. So let's introduce ourselves to the alkenes. All right, just in case they want to get very specific in terms of questions here. What are we supposed to know about the alkenes? Well, trying to find the summary here, but then summary is not. Well, one of the things we need to know the difference is between the two of them. So let's start with there. Everybody seeing this?
Yes, sir.
Alkanes and alkenes. All right, saturated is a term that they will use to refer to the alkanes. Oh, and because, well, it's all single bonds here. All single bonds here, guys. So there are no double bonds in the alkane. So that's why saturated means they're full up. Every room book out. All right. They are saturated because they have the max number of hydrogen bonded to each carbon. So that's alkenes. However, the unsaturated one now, the alkenes are described as unsaturated because they don't, or they have double bonds that don't have the maximum number of hydrogens on each carbon atom. So again, we're seeing this compound here that has a double bond here. This part of the compound could hold some more stuff, but then no, this compound decides you want to have a double bond with carbon here. So just remember that a double bond, it is, you know, it's robbing the compound of two atoms, really. Two more atoms to be involved here. So this is why it said it's unsaturated, because it's not filled up. All right, guys. So you guys are unsaturated now because, well, you don't know enough. There's a lot of potential you guys have, and you have not realized it, especially as it regards to this exam that's coming up. Saturated is when you're ready for exam and you can't wait to do it. You know, because the knowledge is there and the confidence is high. So you guys need to get into the habit of confidence going into an exam and stop having doubt and panic and negative energy. You know, I don't want anybody panicky or anything and fraidy. We're taking the time, we're simplifying this thing and know the thing. You don't have to do some work after class on your own. And I am focusing on key terms here. No, so saturated and unsaturated, these are actually terms used to refer to hydrocarbons. And so instead of calling them alkenes, they could say unsaturated hydrocarbons. All right. Instead of using the word alkanes, they could say saturated hydrocarbons. All right. So that's the story here. Again, this is just intro stuff. Any questions here, guys?
Oh, no, sir.
All right. Let's go one step further here. Here's a list of the alkanes that you would want to be familiar with here. By the way, alkanes and alkenes. So on the left they have alkanes, on the right they have alkenes. All right, so they have a list of them here. We're going to separate them. So remember that alkenes are saturated hydrocarbons. All right, alkenes are unsaturated hydrocarbons. And here's a list of them. Well, C2, well, of course, we have a general formula and we have a molecular formula. So we're going to specify that this here, what you see in here is the molecular formula. All right. Which is telling you how much of each atom is present in that specific compound. Look at the naming that they use here. Meth for 1 carbon, 2 carbons is eth. All right, so, all right, 3 carbons is prop. All right, 4 is but. All right, 5 is pent, as in the word pentagon. And then 6 is hex. So you get used to the name in there. All right, so all of these are molecular formulas. But CXC will ask you about 3 formulas here for organic compounds. One is molecular, the other is general, and the final one for organic chemistry would be structural. So these are all the molecular formulas. All right, now the same prefix used. Anytime we have 2 carbon is the prefix eth we use. For 3, it's prop. So you're beginning to see the trend here. All right. The naming is, the prefixes are the same. So prefix plus "-in", and that's a suffix. And then for the alkene, it's the prefix plus "-ene", as in "ene". All right, everybody seeing the pattern?
Yes, sir.
All right. So that's that. So that is it. I mean, nothing much here. Just to know these prefixes and apply them. Now that we know this information, we can go back to the question and try and tackle it. All right, so we know that compound G have a double bond and compound F has no double bond. So suppose you were asked to write down the homologous series to which compound F belong. What would you write? What series does compound F belong to, class?
Alkane, sir.
So what took you so long to say that? Fear? All right. So yeah, alkane is the answer. Compound F is alkane. What homologous series? So this is the alkane, and remember this is the homologous series here. All right. Let's write that there, because person's not revising the notes. Actually, this was start already. I believe it was sent in the group last week, but nobody takes up book again. All right. So alkane is homologous series here. That's the group to which this belongs. But then what if they ask for the specific name of the compound? What would it be? We have to check how many carbons are present in the compound F.
Butane.
So, okay, that's UKC.
Yes, sir.
And very good. This is actually butane. So we have our butane there. So we know quite a bit about compound F. Let's look at compound G now. We know that we said earlier that it's an alkene. So this is another homologous series, but it's with double bonds in there. So the alkene group. What would be the name of the alkene?
Butene.
Okay, who's that? Kimberly.
Yes, sir.
Okay, very good. So we have butane on the left and butene on the right. Everybody see that? Everybody okay with that?
Yes, sir.
All
Yes,
right.
sir.
Good. So now, the first one, state one physical property that is common to both compound F and G. Physical property, one of them. Look out for these questions, guys. What I mean by physical property? In these questions, physical property mean solid, liquid, gas, and really the state of matter and the boiling point, things like that. But
Oh, sir, so both of them would be gases at
yeah,
room temperature?
yeah, you would say that. What time of the gas is at room temperature? So that's one. Simplest one that. All right. So yeah. Everybody, yeah, that's so both are gases. And that's another thing too, guys. Not only should we know the names, but the states are important. And as soon as I find this summary of all of those, let's see. In fact, we need to look at the physical properties of alkenes and alkanes, and they start out being gases, guys, and then as we go down that series, it turns into liquid and then solid. So let's go back to this list here, guys. This is useful for that information. And let's go here. Let's put this in blue here. So the state our physical property, our state. All right, so methane is a gas, ethane is a gas, propane is a gas. This is actually cooking gas. Butane is a gas, but this gas now will turn into a liquid at 0 degrees. So if you can cool it down to 0 degrees, you get it. It looks like a liquid, and of course you have to push it under pressure, and that's how you can get it in the lighter. So those of you who use lighter, that's actually butane. It looks liquid, but it's only because it's under pressure and it was cooled to 0 degrees before it went in there. Pentane now becomes liquid. And these are very light liquids, very volatile liquids that can easily evaporate. But liquids nonetheless. All of these are liquids. So that's what they mean by physical properties, guys. Ethene is a gas, propene is a gas, butene is a gas. And that's for the purpose of this question. To confirm what pentene is. Pentene might just be a gas as well, but need to confirm that. Certainly hexene is a liquid though. Pretty sure of that. And then of course, this here, liquid. Actine is a liquid. And of course, nonene is also a liquid there. All right, so interesting names for these compounds, but just know the prefixes, them tell you how much carbons are in there. All right, and this is the easiest answer here. One physical property, they just say one. There are other physical properties, but let's stick to the simple ones. Physical property, limited to state of matter, guys. And you find there. All right, they are both gases. And full stop. Any questions?
Sir, how many carbons would it need to be a solid?
Very good question. All right. So for that now, we would go to this fraction, this chart, and we could actually see here by the time it reaches 10. Although this is not a good thing to use though, because hydrocarbons can have a straight a sort of straight line structure, and then that kind of usually keeps it in the liquid state. But if you have one that have C10, and I think you have one with C10H8, if memory serves me correctly, no, that is solid, and that's due to, so by the time it reached 10, to answer your question long and short, really, by the time it reach 10, depend on the shape of the compound, Kimberly, then it will be solid. And we'll start seeing, we're seeing the first solid form here. Yeah, so, and also in that case too, it will not be an alkane or alkene. There are other groups that are out there, but then CXC not asking about that. So maybe the better question to ask would be to say, well, at what how many carbons would it take for an alkene or an alkane to become solid? And that's a different one, because the answer to that is right here, 40 carbons for paraffin. So if it's an alkane, then it needs to have up to like 40 now to become solid. So otherwise, from the first 4 in the series, if we go back to the list here, the first 4 are gases. But then if we were to continue this down to C40, we're going to get solid. So it would be like C40. And then, of course, there's a little formula for these. If you notice that for like you have 10 carbon here and then 22, there's a set formula happening. That's called the general formula. General formula is actually CnH2n plus 2. So Cn meaning that for every carbon atom, there's a certain number of hydrogen atoms. So 2n plus 2 there. So for example, if the molecule we're talking about, guys, is an alkane that has 1 carbon atom, the N would become 1, and the same 1 would be here where the 2N plus 2 is. So 2 times 1 is 2 plus 2, that's 4. That's why the formula for methane is CH4. Hope everybody is seeing that. All right. So if this compound, so this is the general formula. This is the general formula for the hydrocarbons, for the alkanes, CnH2n plus 2. So with that said, now, when we go back to this list, we can look at it with more clarity here. If it has 40 carbon atoms, then 2 times 40 plus 2 is what number? It's going to be C40. 2 times 40 is how much?
80.
80 plus 2 is?
82.
All right, so this would be a formula here, guys, for paraffin. And it's called paraffin, but I don't know if a prefix for 40. So let's call it that. Maybe we'd have to go to Latin for that one. Think is some quaternary word. I don't know, quatern, not quaternary, but Spanish is cuarenta. But all right, let's just go into this. So it's actually called paraffin wax, and this is actually solid. So if you notice with candle wax, it's easy to turn into a liquid. You touch liquefier, it just will melt. So C40H22. That should answer your question, Kimberly, though. That's about 40 the alkane will need to become solid. All right. So that takes care of that. Let's go back to the question, because these questions, as you say, guys, can be expanded a whole lot. They say here, state which compound FRG will react with bromine in the dark. That's a common question here. So which one of them would react with bromine? So what they want us to know here, all right, so it's actually this one. All right, so no other window. All right, so there's, get through this thing here. right. Anyway, so they want us to know the reactions here. So reactions of alkanes and alkenes. This is something that you're going to have to, well, read up on your own, but they did say that they will send it in the exam. We have to be ready for that one. All right, long and short of this, guys, is that alkenes react more than alkanes. They expect you to know that. So the double bond compound will react more than the single bond compound. Can anybody guess why? Yeah. Put in this here. So let's see what's happening here now. Oh. No. Well, so nobody knows why or can guess why. All right, we have to go back to basics. When all right, how do atoms bond together? All right, which how atoms bond together? We learned, we just do bonding couple weeks ago. How do atoms bond together?
They share electrons, sir.
All right, so electrons, that's the key word. When you talk about bonding, we talk about electrons. Everybody get that?
Yes, sir.
Yes, sir.
All right, you see the silent treatment, I get to know that's why I don't know if learning is taking place. All right, bonding involves electrons, either them share or them gain or lose electrons. All right, in this case, when you're talking about hydrocarbons, they are all sharing electrons. All right, so that's all covalent bonds here because these are non-metals. Carbon and hydrogen are non-metals. All right, now, so they are sharing electrons. So now what is happening here? This double bond means that there's more electrons there. All right, more electrons there means that there is more possibility for bonding to take place there. Does everybody understand that? Each line in this diagram is saying that hydrogen has 1 electron, carbon has 1, so them sharing electrons. This is the sharing. All right, so when you check it out, hydrogen have the 1 electron, carbon have the 1 electron on the outside shell. And see, even in the same exam, them say one of the topics is I believe atomic structure. So we have to know about all of those stuff. All right, so I don't want you to park anything we learned before and put it one side and say that's not required here. Everything is required in chemistry. All right, there's bonding taking place here because chemistry is the study of bonding. You have to say it because that's a reaction taking place. So if you check it out, the bonding around this 1, 2, 3, 4, 5, 6, 7, 8. You know, that's the full. This is why this compound is so stable. Right? The electrons are bonded, they are shared, and then hydrogen and carbon are very peaceful neighbors. So it's a very stable compound. And it's called an alkane because it's well, it does contains carbon and hydrogen. So that's what the usually prefix alkane means. Alk usually means that carbon and hydrogen is there. So alcohol and so on, this is saying, what the structure is, carbon and hydrogen. The hull part in alcohol means that there's oxygen present. So, this is how you have to learn chemistry. You can't learn it like, say, sir, they teach this. You have to get it in your vocabulary and see things around you and say, oh, that it is. All right. So names are similar because the name, they mean something. Everything we learn is either a prefix or a suffix. That's what it is. So I don't need a dictionary to find the meaning of word. I know what the prefix mean. And when I see it in another word, I can just say, well, it's that it mean. Anyway, so now if I shake up on learning or something, because this is not the time to be afraid or laid back or overly cautious. You have to just be brave and just attack the thing. So all right. So what I'm saying here now, guys, is that this double bond here have more electrons. I'll draw 4 dots here. These are 4 electrons. In all of this compound in F, it is balanced. So therefore, there's no way. It's not very easy for a compound to another substance like bromine to come in and say, well, we want some electrons. It can't get it so easy because it is what? Saturated. Right? It is saturated. It's a saturated alkene. We just learned that word a while ago. Saturated means say full up. So if anything come in for a little space, now go get it. Alkanes do not react easily. Does everybody understand that?
Sir, repeat, please.
All right. You have to go play it back because a lot of things are said. All right. But this is a saturated alkane. All right. So that's it. Anyway, this double bond here means that there are 4 electrons there waiting to be attacked. The bromine can't get any of these. The bromine can't trouble this side because again everything here is so full. But I watch them electron here. But then when you look at this now, there is 4 free electrons. You have to say no because these are unpaired. Nothing is there. No hydrogen is bonding to this. So what's going to happen now? Bromine will come and say, oh, I see 2 liquid electrons here. What's the formula for bromine? Formula for bromine supposed to be Br2. So a person should know that. But anyway, bromine is there. Bromine comes and bromine can get these 2 electrons. And so it will react with, them say will react with bromine in the dark. Definitely compound G is the answer. And so there you go. Now, remember that we use common sense to show you this, guys, because I don't know bonding. You don't need to know organic chemistry for that. You have to talk about bonding. So bonding is all about electrons. So if electrons are free, they will bond. And free electrons are in the alkane. This is unsaturated because of the double bond. So I'm using the words in the vocabulary where you're supposed to get familiar with. All right. So it's a saturated hydrocarbon, really. That's the right term. Unsaturated hydrocarbon. Anyway. And unsaturated means not filled up. So compound G is the answer there. And then now look at this. They are asking you, I draw the fully displayed structure of the product form from the reaction in C2 above. They wanted to draw the structure of C2. Now, notice that compound G will react with bromine. This in the dark. In the dark. Keyword here, in the dark. Compound F can react with bromine, but not in the dark. this is, although I said this now full up, we say that bromine come to it and can't get any space in it. But you can create space by using light. In fact, sunlight can do it. So sunlight can actually create some space here, because whenever sun is exposed to an alkene or an alkane, it does space out the bonds a bit and allows the reaction to take place faster. And then if compound F, which is butane, comes with reacts with bromine, gets in contact with bromine, a reaction will take place if light is present. All right. If light is present. So then that is it. But the question says in the dark. So compound G in this case would be butene, and which is an alkene, and alkenes react in the dark with bromine. So, all right. So I'm leaving you with that information. And the question goes on to ask a fully displayed structure of the product that is formed from the reaction. So what I want to say now, if butene reacts with bromine, so that's what they're asking you for. They're asking you for from the reaction. So it's butene plus bromine. All right. So butene has the formula C4H8. You know that alkenes here, if we count it up, 1, 2, 3, 4, and if we count the hydrogen, it's going to be 8. So 1, 2, 3, 4, 5, 6, 7, 8. So C4H8, and that's going to react with bromine. Bromine gas or liquid. Yeah, it could be both state or matter, but so they didn't specify which state it in though, but let's treat it as a liquid. Br2 is the formula for bromine, guys. So we write Br2 for bromine, and there will be a reaction between these two in the dark. All right. So, and they say in the dark means that there's less energy available, but once bromine sees those electrons, it doesn't need any light for encouragement. So what's it gonna do here? Butene will be drawn out like this, and they say the product that is formed. So when you draw butene, what it look like? All right, so it's gonna be C, and it's gonna be 4 of these C's, and then when I put the double bond here and put there, and say fully displayed, so we have to go account for everything here. All right, remember that each carbon has a maximum of 4 bonds because carbon is in group 4. This carbon here, this one in the middle here has 1, 2, 3 second carbon atom here. So what's gonna happen here, it's gonna be, this can hold 1 more, and so it's 4 there. Now look at this one, this can also hold 1 more. Let me see if there is 1, 2, 3, 4. This carbon here has 1, 2, 3, so it can hold 1 more there. All right, and then this one now can hold 3 more. So if you check in a organic molecule, in an alkane or an alkene, even alcohols too, any one organic compound, right? Once there's a carbon in there, it is bonded. It has to have 4 bonds to something, right? So that's a rule there. All right, 4 bonds must be around the carbon at all times. And even if it's a double bond, this double bond counts as 2 and then 1. So this will be 2 here, 1 and 2. That will make it 4. So that's okay. All right. Now they said the product is what they want. So if bromine should come into this now, let's use a different color for bromine. Let's say bromine comes in now. Bromine will be going after this. So bromine comes in. All right, so I'm gonna add Br2 there. And so what would happen here? Well, if these 2 electrons are grabbed by bromine, it's gonna break the double bond. So let's go ahead. And remember that what I just draw here, guys, and because some persons either probably not at the screen now or distracted, probably texting or doing a lot of stuff or don't understand and not saying anything. And so because I don't know, then I have to assume the worst. So let me just all right, let me just remove that. It's not being removed. I think this thing is so I want to remove some of these things. Let's just remove this. All right, there you go. Trying to free up some memory here. All right, there you go. All right, so now guys, I was saying no. This is what butene looks like by itself. Everybody seeing this?
Yes, sir.
All right.
Yes, sir.
All right. Now, when bromine come into the picture, bromine will break this double bond. So I'm trying to reach for this double bond. At least one of the bonds here, because it's gonna not reach for both of them, but reach for one of the bonds there. It's actually gonna break it. Is it there? So PowerPoint use up memory. Let me see. I'm gonna take up this, close this, and reset topics here. This is what for chemistry. All right. So while this all right. All right, what's happening? Okay, so this is actually so what's gonna happen here is that one of these double bonds should break into two and bromine comes onto it. What's happening here? Maybe if I stop the streaming and see. All right. Should work better. Yeah, close out them. Yeah, that should help. All right. Well, some of them here as well, because I'm not understanding. All right. I probably want to update. All right. Anyway, well, that is taking place. Oh, yeah, it's actually saving. All right. I probably need to make it smaller. All right. Probably while that happens, I wonder if I could probably use Word and just dry it out and we're not fixing. All right. No problem. To be thinking quite quickly here. All right. So this is to draw. Nothing there. Okay, so here so. My machine need for restart. All right, I'll do this now.